In this video, we're going to look at a solution to task 7b from the Electronics and Control course notes. As an example in the notes and in previous videos, we begin by identifying rows in our truth table which have a 1 in the Z column. So the first row and the third row both have a 1 in that column. We write an expression for Z in terms of A and B, where we have the not symbols, the letter with a bar above it if we have a 0, and we have the symbol of the letter with no bar if we have a 1 in that column. So in the first row we have a 0 for A and a 0 for B. This means not A and not B, if they're both zeros, will give us Z as 1. So we can write Z is equal to A bar dot B bar. That means not A and not B. Looking to the third row of the table, we have A is 1 and B is 0, giving us the expression Z is equal to A, because we have 1 in the A column, dot not B, or B bar as we refer to it, meaning we've got a 0 in the B column. This means that for our whole table, this is the expression which will give us Z is equal to 1. Either we have not A and not B, or, which we represent with a plus sign, we have A and not B. If either of these two conditions is met, we'll get a 1 in the Z column. So this expression here represents the whole circuit. And so that will be the output of our circuit over here. We're going to have Z is equal to A bar dot B bar plus A dot B bar. When we have a plus sign in the expression for our output, that means we have an OR. And that's always the first gate we're going to draw when that is the case. So leading to our output, we're going to have an OR gate. And either side of that OR gate will be the two sides of what is between the plus sign there. So we'll draw a wire path coming out of that. One of the inputs is going to be A bar dot B bar, and the other input is going to be A dot B bar. These values have been taken from here and here respectively, either side of that plus sign. We can now see what we have as our two inputs to this OR gate are both AND functions. There's a dot in between them, so it means that these must be formed from two inputs to an AND gate. So on each side here, we have an AND gate representing the fact that we've got an AND function coming out of it. And in each AND gate, we can tell what we've got going in by what's on either side of the dot. So this top AND gate here, we must have A bar and draw that again, and B bar as our inputs. And the bottom AND gate here, we must have A and B bar as our inputs. And now we're at a point where every input we have to connect is either A or B or not A or B. So we know our two inputs to the circuit are A and B because these are the columns in our truth table. So for the first AND gate, we need not A. So we can see we have to have a NOT gate in here to change A to not A. So we run our A input through a NOT gate and connect that up to the first AND gate. The second AND gate down here requires A as an input. So we can just take a connection straight from the A source and connect it up here. Our second value is B, and we have not B going into the first AND gate. So again, we'll need to create a NOT gate here so we can pass our B signal through the NOT gate, and then carefully crossing over this wire here, we'll connect this up to the second input for the top AND gate. So now we have not A and not B entering that AND gate. And for the second AND gate, it also requires not B. So unlike last time we took our source from before the NOT gate. That's what we did for A. So I could do that for B if I wanted to. This line here is not passing through that NOT gate there. For B, we want it to have passed through the NOT gate because we also need not B here. So we take a connection from here because at this point in the circuit, we have the value not B coming out of that. And we can take a connection off that to go into the top AND gate and to the bottom AND gate as well. And so that's how we form this circuit. Because we had more than one option for Z, and being 1 at the start, we start with an OR gate. Each of those options going into the OR gate is a combination of two versions of A and B, either A and B or not A and not B. So we separate those with AND gates, and then we link these back to the original inputs either directly or by passing through a NOT gate first. And that concludes task 7B from the course notes.